Okay, thank you very much. Actually, yeah, thanks a lot for inviting me. I usually don't get much opportunity beyond the classroom to showcase some of the kind of research that we do in my lab. So I think this is a good opportunity, especially if it's recorded and it's put online somewhere. So for this talk, I'll keep it fairly high level, and I'm more than happy to go into details if anyone is interested in. So maybe at the end of my talk or even in between, if there's any questions, you can feel free to just stop me and ask me questions. Okay. Right. So uh, artificial intelligence or machine learning, I use those words interchangeably, but these are being more and more prevalent in society. So a lot of companies are trying to use this kind of technology in their products. This is well known for companies like Google and Facebook and Microsoft, but even beyond these big companies, there's a lot of interest in using these kind of technologies in widespread deployment of this across many applications. Now, once we do that, we actually have to also start thinking about other issues that this technology has, and which has so far not been really addressed. I would say it's acknowledged, but it's not really been addressed fully yet. And these are the aspects of fairness and privacy. So I'll describe what this means. I'll actually go through a lot of examples of what I mean by fairness and privacy in AI, and I'll point out the problems. I will probably not offer many solutions in this talk. I tried to stay away from the gory details of how to solve these problems, but I want to introduce these problems to all of you. Okay, so this is actually one of the core areas of research in my group. So a lot of students in my group, grad students, they work on this topic. So, so you must have all heard about artificial intelligence. It's especially in the news these days for good or bad reasons. Or maybe I've heard about autonomous vehicles. So a lot of this kind of technology is being used for autonomous vehicles. So for example, these are some of the main subtopics within artificial intelligence, and we have made a lot of progress in these subtopics, especially in the last 10 years, thanks to deep neural networks and deep learning revolution that we had in AI. So the speech processing, image analysis, or computer vision, any kind of natural language processing, and even robotics. So if you're all using smartphones, either Apple or Google or Android, so you have speech processing, very high quality speech processing. So you can say something and they recognize you. Maybe Siri not so much, but definitely Google does a very good job of this. Image analysis is critical for autonomous vehicles and in general for lots of other applications, especially medical applications as well. Okay, so one thing that has been the key driver of the progress that we had in this field is three things. One is data. Now we have access to a lot of data. Everyone has a cell phone. We capture so many photos. We take so many photos, and all of those are uploaded somewhere, right? And we are writing so much online. There's so many websites and so on. So there's a lot of data there. And we also have very good compute. Thanks to Moore's law, things are just getting better and better. Lots of GPUs, parallel processing. And we also have algorithms now. So I would say these algorithms are not new. We had them 30 years ago as well. 30 years ago, we didn't have the compute and the data. Now we have those two, and now the algorithms actually do become very powerful. So we made a lot of progress, and this is not what I'm going to talk about. So there's other sources where you can talk about all this progress over here. But I want to highlight some things about some consequences of this progress in the real world. Okay, so what's happening in the real world, state of affairs? So if you follow the news, you may have come across these kinds of articles. So this is a chatbot that Microsoft tried to release. So this chatbot basically it was trying to learn from the tweets of other people, and then it started to automatically put out tweets on Twitter. So within a couple of days, this chatbot, I think it was called Tay, and within a couple of days, or maybe within a day, this chatbot started saying very objectionable things. So basically, it went ahead and looked at all of Twitter and all the tweets that people are using, and it picked up some not so nice things and it started really spouting those out. And Microsoft had to take it down. This is one of the consequences of relying purely on data, especially data that's unregulated and you're just taking data from everywhere, right? So these kind of AI systems that are built on top of data, they will inherit any sort of bad or any sort of unintended consequences, like objectionable things and so on. It'll just inherit them. Right now, the tools that we do not have the proper algorithms to control for these kinds of things. Here's another one. Maybe some of you have used this app or maybe not, I'm not sure. So this is called Face app, and it was a very popular app. Especially, basically, you could upload a photograph of you, and it would basically it has a hot filter and makes you look pretty or something like that. But essentially, underneath it, what it was really trying to do is it was just making the skin lighter. That's what it was doing in all of the photos, mostly. Now, this is okay, maybe in some cultures, and maybe it is desirable in some cultures, but it is, in general, it's not okay across the world. Some people take offense to this, right? Again, this was purely because they built this app using data, and it was trained using a lot of data from the Western part of the world. So we had a lot of Caucasian faces in the data, and basically it learned that if I want to make someone pretty, I just make their skin lighter. So that's what it ended up learning. You know, so that's an unintended consequence, and again, we don't have algorithms to like control for these kinds of things. Here's another one. I think this is in the New York Times a couple of years ago. So this was a study out of MIT, um, where they went ahead and looked at many different face recognition APIs. Almost every company now has so Microsoft has one, Amazon has one, Facebook also has one, probably Google as well. So there, what they did is they took these different APIs, publicly available APIs, and they basically started analyzing their performance across different demographics of people. So here I'm just showing you one example of a skin color, but this is not the only thing that they did. But one thing that they observed, and this is across the board, which is that, you know, if your face is lighter, so if you have a lighter colored skin, then the algorithm has only a 0.7% error. So it's fairly accurate if you have a light colored skin. But if you have a darker colored skin, then your accuracy is much lower. So it makes a lot more errors, 12% or 13% errors. It's not just with skin color. They also found this exact same thing with respect to, let's say, age as well. So if you're sort of middle-aged, maybe between 20 and 50 years old, then this algorithm works very well. But if you're very young, like maybe a kid, less than 10 years, or if you're pretty old, maybe 80, 90 years, again, the error rates are much higher.
I have a question.
Yes, go ahead.
Why are the error rates higher for those different circumstances? Is it just
Yeah.
lack of data, or is it something else?
Yes, very, very good question. So, in the entire machine learning pipeline, you have a couple of things. You have the data, you have the algorithm, and then you have some objective that you're optimizing your algorithm to. So this problem is occurring because at all of these three places. So first of all, data-wise, majority of the data that's available on the internet is biased towards maybe age groups of 20 to maybe 50. There's not so much data about very old people or very young people. So that's one issue. Even if you sort of somehow balance for that, and people have tried to do that, you say, okay, I'm going to have equal number of people across all the age groups, or equal number of males and females, and so on. That still doesn't fix the problem, because the problem is still there in the algorithm. The problem is still there in the objectives that you're using to optimize your algorithm. So It's pervasive in the entire machine learning pipeline. Right now, we are at the stage where we are identifying that these issues exist. We have not fully understood which parts of the machine learning pipeline contribute to this problem the most. And that's where the current research, state of the art research is at. It's in more of understanding where the problems are and then trying to come up with some solutions to address that. Does that help?
Yeah, thank you.
Sure. Yeah, so this issue is it's much larger. Even for example, if you are Caucasian face, then your performance is higher. If you go and apply the same algorithm maybe in China or Japan or India or somewhere in the East, or maybe you go to Africa, again the performance is much lower. That's one aspect of that is because of data. And you can also it's also easy to see, right? So if you have a civilization or a society where internet access is much more pervasive than other places, maybe in Africa or some other countries in Asia, maybe the internet service is not so good. So people are maybe taking photos, but they're not maybe uploading them, or maybe they don't have access to very high-end smartphones and so on. So this is imbalance in data. The majority of the data on the internet is from people who have the privilege to be able to take these photos and upload them and use these services and so on. So there's implicit bias over there. Now, why is all these important? This is important because these days, companies and government is trying to use machine learning algorithms or AI systems to make automated decisions. So for example, in some countries where they actually use your face to identify who you are, and based on that, you have some privileges. Maybe if you're a female or a male, you have some privilege. If you're an older person, you have some privileges and so on. That may not be the case in the US, but in some countries that it is set up like that. So it is important that these methods and these AI systems, they work equally well across the board. Otherwise, some segment of the society might be disproportionately affected. And that's not a nice thing. Here's a much more recent. I think this was last year. The company in New York called Clearview AI. They were basically going and mining billions of photographs from Facebook, and they built this gigantic face recognition system for the police forces, I think, across the US. Um, so law enforcement, basically. But the main issue there was none of these people have given consent to use their photographs to help build this face recognition system for this company. So they have billions of this photographs. So it basically took photographs from most people in the US. We just did not know about it. This is actually a dangerous thing, right? So this is a very slippery slope. We have to be able to control who gets to use our data, and we already saw that even if they use data, there's issues with being discriminative and biased against different segments of society. Okay, so basically the conclusion that many people have figured out across domains. I've showed largely images, computer vision kind of applications, because that's what my work is in. But this is exactly the same thing that people have observed in natural language processing, and also in speech recognition and so on. So it's across the board, across all applications of AI. We see that these systems are very effective, especially these days, right? So they have very good performance, but they have issues. One is that they're biased, and this is bias against different segments of the society. And they also help violate a lot of users' privacy. And they're not very trustworthy. So I'm not going to be talking too much about the trustworthy part. This goes into the security aspects of AI systems. So these AI systems are very easy to actually attack and manipulate as a malicious entity. So they're not that trustworthy. But even then, they have all these issues. And this is basically where the entire community is at. We have figured out these things work very well, but now we have to start thinking about these issues. Okay. So today's agenda, I'm going to briefly, at a very high level, try to say how to build this kind of AI systems that are fair and trustworthy. So that's the goal here. I won't be able to go into too many details, but I'll just try to give a very high level ideas. So the way to build these kind of fair and trustworthy AI systems is, one is to control for data. So you make sure data is equal across different segments of the society. But I would claim that even that is actually not possible to do. You will never be able to get equal amounts of data for every different segment of the society. That's just not possible. That's a fact of the world. For example, if there's a tribe somewhere in I don't know, in South America, that they don't want to, they probably don't even have access to a lot of internet, or they don't have photographs and so on. There's no way you'll be able to get that data to be able to include it in your system. So it's just a fact of like different segments of society have different access to this technology, smartphones and so on. So you have different amounts of data from each. So that's one issue, the data issue. Uh, the issue that I'm going to try to talk about here is, how do we control the algorithm, the middle part. So the last part is the objective. So I won't have time to talk about that, but let's talk about the algorithm. So the way to control the algorithm is to somehow control what is called semantic information in the data. Semantic information basically is information that has meaning. So information maybe that corresponds to your gender, information maybe that corresponds to, in a photograph, whatever parts of the face or whatever features in the face that convey that you're of this gender, or convey that you are of this particular age, or convey information about, your ethnicity or something. So semantic is just a word which encompasses all of this. So how do we control for this semantic information in the data? So that's basically how you can make these AI systems fair. So we have done a lot of work in extracting information from data, and this is not something that we started just now, but we have been doing this for over 100 years now. So for example, I don't know in any of your classes if you have heard about principal component analysis. This is one of the simplest algorithm that you'll probably learn in a linear algebra course. Essentially, what this is doing is it's taking your raw data. This could be an image that you have, and it's making it compact. So instead of, let's say this image is a megapixel image, instead of having a million numbers to represent this image, all of these algorithms, what they do is they compress that information into a vector of maybe just a couple hundred numbers. Okay, so from a million you go down to a couple of hundred numbers. So that's the representation of that image. So this couple hundred numbers have all the information necessary for you to get back the image maybe. So across the 100 years, we designed the algorithms to extract this information, and these algorithms were designed by hand. So had a PhD student sitting working for 5 years for his PhD and trying to come up with one algorithm which to do this, and that's how we operated until very recently, until 10 years ago. And then we were controlling some mathematical aspects over here while doing that. But I would say that in the last 10 years, this hand designing from students, that basically disappeared, and we have these neural networks that are doing the job for us now. So there's no student sitting and saying, okay, extract this nose and the eye and the mouth from the face, but it's just a new neural network which is learning how to extract this kind of information automatically. And here we're still controlling for mathematical concepts. We are not controlling yet for semantic concepts like the ones that I mentioned earlier. So what is the consequence of not controlling for the semantic concepts? It's the following. So I have a lot of images here, and let's say I'm trying to build a machine learning system that will maybe try to identify what gender you are. So arguably, this may not be a perfect process, but there are commercial APIs which already try to do this, especially from Microsoft, I think. And again, we just like the recognition case, we also see that there's discrimination across the different demographics of the population. You can even do things like, I'm trying to recognize whether you're trying to smile or not, but Through that process, I'm also able to extract information about your gender. So let's say I only provide my image and I tell Microsoft only use this image to extract the whether to say whether I'm smiling or not in this photograph. That's the only thing I want you to do. However, as a consequence of solving that problem, Microsoft is also able to extract a lot of other information, which I don't want to reveal it to them. Something like what ethnicity I am, or my gender, or any other information that I feel is private. I only want them to be able to extract information to allow them to say whether I'm smiling or not. But through that process, they're able to extract all these other things. So this is the privacy leakage problem. So you give them data for one thing, and they end up using the data for a lot of other things, and which you never agreed to in the first place. So even with neural networks, this is basically what happens in the real world. So why is this happening? Even when we have neural networks, the reason this is happening is because neural networks have a very dark secret, which is that they absorb any statistical correlations in the data, whether it's good or bad, or whether it's correct or not correct. They just absorb anything that's there in the data. And we right now have no algorithms to control what information is getting extracted from the data. Okay, so now the question might be, so what? Okay, let these machines, just let these algorithms extract whatever they want, right? So what's the issue? Well, this causes a lot of problems. One, I've already been talking about, bias. The other thing is it actually more dangerous scenario here is overfitting to a particular domain. So let me give you an example. Let's say I'm building an autonomous driving vehicle, and I'm building this in California. So there's a Tesla sitting in California, and they're training their autonomous driving system for California's weather, where it's throughout the year, maybe it's mostly sunny and it's dry. And then they bring that Tesla, and then they try to run it in Michigan. It's very gloomy, it's snowing and raining, and it just doesn't work. It's going to go and start hitting things. Okay, so this is actually a big problem in machine learning. It's called domain adaptation, and this is a consequence of absorbing all these correlations is this domain issue. And you also have privacy leakage, and the other thing is its lack of robustness to variations. And this is actually a big problem in machine learning again. So you make small changes to the image, you add noise to it, or as you're taking a photograph, maybe your camera is moving and there's some blur going on in your image, and that throws off these algorithms. These algorithms are not robust to these kinds of small variations. In fact, you can even custom design these variations where the algorithm gives a completely wrong answer. So for example, I can take a stop sign symbol, I can just manipulate a few colors somewhere on the stop sign symbol, and now the autonomous car is going to not identify it as a stop sign at all, and it's going to just go through. So that can have very dangerous consequences. So all of these issues, and there are more, I'm just listing a few of them here, are happening because of the fact that these machine learning systems, they just take data and extract everything out of it without any control. So the key progress that we're going to make in the next 10 years of machine learning is we're going to change from controlling mathematical concepts to controlling something called semantic concepts. And semantic concepts are concepts that we identify with. For example, semantic concept could be age or gender, or we could say it has to work well in winter and summer and rainy season, right? So these are semantic concepts which we can identify with. We have meaning to it. So this is where the community is heading. So we have identified all these issues and we know how to fix it. The way to fix it is by controlling the semantic information. And this is what the community is going to work, I think, over the next 10 years to help solve all these problems. Uh, so I'm going to just talk a little bit, show an illustration of what this concept is, semantic control means, and then I'm going to maybe show you some results of what you can have if you have these algorithms. So for example, I have these two images here, and I'm just simply trying to predict whether I'm smiling or not. In this case, actually, both are smiling, or maybe it's debatable in the second case. But as I'm building the smile detection algorithm, it also is extracting other information about my gender. So there is some gender information over here, which is causing me to maybe give a wrong answer, even though this person is smiling here. Maybe the algorithm learns that males don't smile as much. It's just that's maybe how the data is, where most of the males are not smiling in the photographs. So because it's biasing itself to the data, it is going to have this information and make a wrong prediction over here. Now the concept is very simple. Now we want to control semantic information, which is we want to remove that gender information over here. If we can do that, then this algorithm will no longer be affected by the gender of the person, and actually try to focus on the mouth and say, oh, is this person smiling or not? And then give a correct answer over here. So we are trying to essentially identify and remove the gender information. So this is what I mean by controlling. So I'm going to say I don't want to have gender information, so the algorithm will try to go and get rid of it. So how do we do this? Well, we want to extract some information from data, and we want to retain some specific information corresponding to a task that you want to solve, maybe like smile. You want to remove undesired information, maybe like gender. So this is the new concept now. So until now, machine learning systems, they were only focusing on the first two. We were only focusing on getting information to help me identify whether solving a particular task, like smile in this case. But we were not looking at what information to remove. We were only thinking in terms of what information to keep or retain. So now the third part is what is going to be new, that's going to be added into these machine learning systems. And I would say that this is the concept over here. Now there's different ways in which you can do this, and there are very complex ways in which you do this. It also introduces some issues in how you design this machine learning systems. But I'm trying to give you a high level picture of what we want to be able to do. So there's a bunch of questions from a technical point of view. How do we control, and can we even control? This is actually an important question. We desire this, but is it even possible? Are there fundamental limitations why we cannot do this? In fact, we find that there are fundamental limitations that you cannot do this in some cases. So we have to identify what those scenarios are. In those cases, you cannot guarantee, or you cannot make your machine learning system unbiased or fair across everything. It's just not, theoretically, it's not possible. Okay, so I had, so the question of whether you can, yes, we can sometimes, but not all the time. So I'm going to maybe skip this slide here. I try to illustrate how we actually might be able to do this, just an illustration. But maybe show you some results on what kind of things you can do if you are able to control for this. So practical applications. So far we are at the stage, the community is at the stage where we are only able to solve small problems to understand the issue of controlling information. We are not at the stage where this is being implemented in large scale systems like at Google or Facebook, because there's a lot of fundamental mathematical and algorithmic issues that are still not resolved yet. So all the data sets I'm going to show you some results on, those are all just small data sets. But here's an actual problem here, where a bank is maybe taking your information and trying to predict whether you are worthy of getting a credit from them. Maybe you're applying for a home loan or an auto loan, and this is what the banks do. They take this information, dump it into a machine learning system, and that will tell you, yes, give him a loan or give her a loan, or no. So of course, we want this machine learning system to focus only on your financial situation to make a prediction, but unfortunately, it's going to make use of other information to make this prediction. So if you use raw data over here, which is just the data that is currently being used, then it's able to predict whether you're credit worthy or not at an accuracy of around 84%. But by doing that, it actually is also using gender information almost up to the effect of 98%. So it is being biased by the gender of the person. Now, if I go and take the data and I just remove the gender part of the data, maybe there's a gender attribute there, male, female, or whatever other attributes. If you remove that, that is still not sufficient because there may be other attributes in the data which correspond to gender, maybe your height. So females are typically shorter than males. So your height is a proxy to tell, whether you're a male or a female. So it's still not enough. Even if I just remove the male information, it's still not enough. There may be other features in my data that correspond to the gender, and the algorithm is going to make use of it because that's what it does. It's going to make use of any information that is there. So this is also not desirable. So then we were able to come up with some solution to reduce this dependency on the gender. In fact, zero over here says that it has completely been able to remove the gender information. So that's what this last column is trying to say. Now now this system over here is an unbiased system. It's not going to be biased by gender. It's going to look at other economic information or financial information to decide whether you're credit worthy or not. And the performance is still reasonably good in this case. So you can actually take a look at these are all the different features that were there in making that prediction. So age, where you work, your actual weight, your education qualifications, and so, and occupation, relation, race, and so on. And the algorithm is suppressing the gender information. You can see the weight it's assigning to this gender is much lower than anything else. But also you see there's a feature called weight over here, the weight of the person. For whatever reason, the bank is asking that information. And that information has strong relation to gender. So males are typically heavier than females, for example. So the algorithm learns to suppress the contribution of the weight of the person also in making a prediction. And you can see that the algorithm is focusing more on capital gains and capital loss. These are financial information, which it should for being able to predict whether you're a credit-worthy person or not. So this is a nice way of understanding and to see that your algorithm is actually doing something meaningful and sensible over here.
Question?
Yes.
Can you, yeah. So is this the algorithm that was developed to determine the bank loan acceptance?
Yeah.
Why is race and country have to do with it?
Race and sorry, country?
Country, yeah.
So yeah, that is one of the information that the bank is asking. We have no idea why. This is just the things that this is the information that they collect and feed into the machine learning system. And yes, I mean, ideally it should not be focusing on the race as well. And in this case, you can actually notice that the algorithm says don't focus too much on the race compared to the other attributes over here. But it still has some weight on the race in this case. And this is something, so it's still not perfect. So we only control for gender in this case. On gender, it's doing a good job, but we have to maybe control for the other attributes like race as well. Yeah.
Okay.
How are we doing on time? I think I'm probably already out of time. Is that correct, Arden?
You can keep going, but if we could wrap it up maybe in another 7 minutes.
Okay, yeah, I'll try to, yeah. So same thing for the gender same thing for the smile prediction from, just images. In this case, if you just use the full image without controlling for gender, the system that is predicting smile also is able to predict your gender up to an 83% accuracy. So it has a lot of gender information over there. So this is the amount of gender information that it has. So this is existing solution. It is able to reduce the amount of gender information. So leakage of privacy here from 21 to 11, but they're still leaking some information here. Then we were able to come up with a system that completely removes this gender information from the. So in this case, what it means is that the system is able to predict whether you're smiling or not, while not leaking any private information with respect to gender in this case. So it's a nice thing from a privacy point of view. It's only using the information, it's only extracting the information that you explicitly consented to, which is, look at the region around your mouth to say whether you're smiling or not. That's the only information it's using. So this is nice from a privacy point of view. So I'm going to skip some of these things, and yeah, so there's other mechanisms to protect privacy of users. One is by controlling who gets access to the information. So that's another way to control privacy. So here's an example of why we need to care about privacy beyond the applications I just showed you. This one is an augmented reality system. Okay, so what these systems do is as you're going around your home and you're wearing this device and doing things, it's actually building a map of your house. That's what these systems do. So this is the on the left over here. I hope you can see my mouse here. It's actually building this map, and this is the red is the trajectory of this device. So as you walked around the house, this is the map it's building. So this is the information it's storing about one particular room in your house. Now, this information, if you're using an Oculus Rift or a HoloLens or any other augmented reality device, it's actually sending this information to Facebook or Microsoft to store in their servers. Now, this information, you might think, by looking at this middle image here, you might think, oh, it doesn't have too much information about my house. It doesn't know what, it only has a little bit of information. But then people were able to come up with an algorithm which goes from this very, very sparse data to this image over here. So this is a reconstruction of that room just from that very little sparse data. So now you're able to see all the details in your house. You know where your couch is, what color it is, and that you have a bookshelf here and you have books here and so on. The last image is the ground truth. This is the actual picture of this room. And if you notice, these two look very, very similar. So machine learning systems are so good that even from this very, very little sparse data, it is able to reconstruct all of this. So potentially Microsoft or Facebook from your AR device, they are able to know everything about everything that's there in your house. They're able to perfectly map it out. They know everything, where everything is. And that's a potential privacy nightmare. Some employee or just a company might go rogue, or they may get hacked. This database might get hacked, and they're able to extract all this. So this is not a nice thing to be able to do. There's more information that's being leaked. So this is the image ground truth on the left here, and then the right is the reconstruction from the machine learning system from very little data, just a few points on this image. So again, this is not a good thing to have. So you can there's actually a nice website here where you can go and play around with these things. So here's an example. So you have this many number of points, and this is the reconstruction of the algorithm. It's actually doing a pretty good job. Now, if I go and increase it to 60%, of course, the reconstruction improves. If I use all the points that I have, then the reconstruction improves even further. So same with the bedroom here and so on. So this is actually a nice website where you can, play around with these things. So this is a simple algorithm, and this is a slightly better algorithm. And you can see it's able to extract a lot more details from information like these point clouds over here. So this is actually a big privacy nightmare for augmented reality devices. Unsurprisingly, Microsoft is most of these researchers are from Microsoft, and they're trying to build AR systems that do not allow this to happen, so that your privacy is still preserved. So I'm going to maybe skip this part here. So one reason why you want privacy is because it's not there in the US, but in Europe, they have this thing called GDPR, which basically says that a user has to give consent for all the purposes for which the data is used. And some states in the US, like maybe Illinois and California, have these kinds of rules, but not all the states in the US have them. But in the future, these kinds of rules or laws will actually start coming. And then we have to be ready from a machine learning point of view to be able to guarantee these kinds of things like fairness and privacy. So my one thing that we are doing in my group is try to use encryption as a way to protect data. So the idea is very simple. You encrypt the data. Now nobody gets to see what the data is because it's encrypted. And now you do all your machine learning operations on the encrypted data. So that is a solution that is very attractive. It's sort of like the holy grail for machine learning and security, but there's a lot of technical challenges to be able to do this. So doing operations on the encrypted data is computationally extremely expensive. So there's a lot of issues over here, and my group is working on these kinds of things. And there are other groups across the US as well trying to use these kinds of things. Okay, so I'm going to maybe skip some of these things over here, but I want to maybe just conclude. So first of all, there are many open problems. So I have mostly described problems in my talk as a motivation for upcoming students like you to know what kind of things you want to be working when you graduate. First of all, the question is, how do we mitigate bias in AI? How do we ensure that these systems do not violate user privacy? And before we are able to do this, we need to understand what are the fundamental limitations in building fair systems or in building systems that are privacy preserving. And there's a lot of other questions which go, but the fundamental questions start here. And then how do we build algorithms? How do we guarantee them? Can we have theoretical proofs for these things and so on? Okay, so to summarize, I would say that the state at which AI is right now is that they work really well, but they are biased and they violate users' privacy. So I try to maybe give you an overview of how do we make these systems fair and privacy preserving. And there are lots of open questions and practical challenges. This is a very exciting area of research. And there's a lot of new students trying to work on these kinds of topics. Okay, so with that, I'll conclude. That's all I have for today. If you have any questions, I'll be happy to discuss. I know I skipped through a lot of details, but I'm happy to go through them if you want to.
I have a question, and I'm not super well versed in this topic, so forgive me if I say something that is inaccurate to some extent. But I was wondering if, when you're talking about the mapping of different like images through these what do you call them, like the goggles, is there anything, are there any privacy concerns similar to that with like Roombas and things that track the things that are in your household?
Yeah, absolutely. In fact, so the example, the AR device example I showed you, the Roomba is actually doing the mapping of your house. That's how it knows, where it has already. So this picture over here, this trajectory, that's exactly what your Roomba will do. It'll build this map internally as it goes through your house to know where all the furniture are, where all the doors and obstacles are. And I don't know if Roomba sends this information back to the cloud, or is it storing all of this locally on the Roomba itself? I don't know that part. But if it is actually sending it back to the cloud, then yes, someone can take that information and build this kind of image of your house. They know exactly where everything is, what couches you have, what TVs you have, and so on. Yeah. Yeah, Roomba, you have the same issue with the Roombas as well. Yes.
Thank you.
Well, these days, I think we also have these cameras, the security cameras. I don't know what they call them. Simply Safe. I think that's one company. Maybe there are other ones. Yeah, so they are constantly collecting information, and they're in fact sending it all to the cloud. And also, if you have these audio devices, the Alexa or any of these Google, I don't know what they call it, the Google Assistant, the speaker, smart speaker, or even from Apple, they are constantly listening to everything that you're saying, even if you're not interacting with the Alexa, it's constantly listening. Now, whether this information is safe or not, we don't know. So these companies, all the companies say that, yeah, we're not doing anything with the data and it's safe and all that. But that's until you hear about, big breach happening at the company and millions of customer information. That's when you hear about it. Until then, all the companies will say, oh, everything is safe. Yeah, so in fact, just even though you might think the speaker doesn't have enough information, just by analyzing how the sound signals are propagating and coming back, people are able to build this kind of images of your house just from speech information. And people, I know one of my friends who is a professor at University of Washington, he does that kind of research. So he's able to take just wireless signals from your router in your house and speech signals from Alexa and try to reconstruct your entire home. So there's technology like that. Okay, hopefully I didn't scare everyone away about, yes, what I wanted to show here is that these systems are awesome, but they have some issues. And these are issues that are not, uh, they are solvable issues. We are just, realizing that these exist. And now for the next 10, 20 years, we are going to keep working on trying to get rid of or make our systems not have all these issues, and then it'll be safe for us to use these machine learning systems at home or personal lives. So yeah, it's just a consequence. Until now, machine learning or AI systems, they were not good enough to be used in the real world. That changed in the last sort of 10 years because the performance of these systems has increased quite a bit. Now everyone wants to use it everywhere. People want to put these systems in your fridge, on your table, and so on. So as you do this, that's when you start worrying about the security aspects of these things. And we are just at the beginning stages of that.
Thank you. This talk was really interesting.
Yeah, thanks, Dr. Boddeti. I have a question actually. So, so when you mentioned you can take out, for example, the gender data, right?
Mm-hmm.
But there's more data in there that can help the system figure out the gender.
Yeah, yeah.
So how do you know when you've pulled out all of that extra information that contributes to the bias?
Yes, exactly. Yeah. So I didn't tell you how, but there is a way to measure that kind of information. And that's what we're actually showing in this last column here. So we have been able to extract everything that's there in the image in this case. These are called measures of dependence or measures of independence. These are statistical concepts, and basically what it does is it looks at, okay, if I have the image information as a vector, I don't know, I'm explaining from a linear algebra point of view. If you have the image as a vector and you have gender as another vector, basically it's trying to look at an orthogonal projection or a 90-degree projection of the data from the gender plane. So that's what it's trying to do. If you do that, that means you are guaranteed to have removed all the information. That's a simplified version of the concept, but in a sense, that's what you're doing. Okay, does that help? Yeah, I know I'm not telling you all the details, but then, because then it's going to become like a lecture.
Yeah. No, that makes sense. That's
yeah.
was good and concise. All right. Well, thank you so much for this presentation. We really appreciate you being here.
Yeah, I'm very glad. Yeah, I just wanted to highlight these kinds of things so that you are all the young people who will be working on these kinds of things in the future. So you are the future of research, right?
Mm-hmm.
So I wanted to, maybe you can start thinking about these things, from a young age, and then it's going to help you later on. And yeah, so far, I guess a lot of other people, and mostly you hear about the good aspects of machine learning from the lectures and courses and the news. So I want to highlight some of the other side as well a little bit here.
Yeah, I learned a lot.
Yeah, so the slides are up on my website. I think I gave the link. So these are just web pages. You can just go through them by clicking your right and left arrow. So you can just go to this link here, and you should be able to see all the slides. They'll be up.
All right, thanks. Yeah, I'll forward that link to the other members of the group.
Sure.
So that they
Okay,
can-
thanks a lot. It was a pleasure, and I hope to maybe be back here sometime later as well.
Yeah, definitely. Thank you so much.
Thank
Thank
you.
you.
Thank you.
Yeah, thank you, Dr. Boddeti.